Now, rational functions. So we've covered the definition of rational functions at the start. So how does it apply for rational ones? Of course, a rational function will happen if you have an algebraic expression which is written as a fraction. More importantly, that fraction should involve a denominator with a degree of at least 1. In simpler words, you cannot have a rational function if there's no variable in the denominator. There should be at least an x in the denominator to make it a rational function. So because you're dealing with a fraction, the main restriction is no zero in the denominator, or the denominator cannot have value of 0. And because we have that restriction, domain and range are automatically restricted. So you will be seeing what we call asymptotes later on in visualizing what a rational function is. So for the domain, again, simple definition, it's going to be consist of all real numbers except what makes the denominator 0. To find those restrictions, we're going to solve an equation. What makes the denominator 0? And then that's what's going to be not included in the domain. So to start with, we have f of x equals 2 over x plus 6. Again, this one is going to simply refer to uh, the domain is only going to consider values that will not make x plus 6 0, which that brings us -6. Hence, your domain is all real numbers except -6, as you see there in both set builder and interval notation. This brings us the vertical asymptotes, as we call it. Later on, you'll see how we visualize the vertical asymptote and how it's going to affect the rational functions graph. Now let's go back to our example from the previous presentations. You remember the combination of two functions, h and f? It is composed as -2 times the square root of 3x over x minus 3 squared minus 4. So how will we determine its domain? Of course, for this one, we're going to need our trusty bit paper. So what we have is for us to find the domain of this composed function, we follow the restrictions. It's a radical, so that means we cannot have um, what's inside it become a negative. So we only need to solve this. From here, we simplify and solve the inequality to find the domain of h of f of x. So, where do we start? Of course, simplifying tells us that we have 9x squared over x minus 3 squared minus 4 greater than or equal to 0. And then from here, we get, um, we have to combine these two as one fraction. So we have 9x squared minus 4 times x minus 3 squared all over x minus 3 squared. Simplifying our numerator gives us 9x squared minus 4 times x squared minus 6x plus 9. Same denominator. Which means we'll be solving the inequality. So that's 9x squared minus 4 times x squared, 5x squared plus 24x plus 9. Oh wait, minus 36, sorry. That's all over x minus 3 squared. So if you observe, our numerator is factorable. It's going to be 5x, then x here. This negative 36, the constant part, which is a 6 and 6. And for us to get positive 24 means we have these signs. So 5x minus x times x plus 6 all over x minus 3 squared greater than or equal to 0. We'll continue on the next video.